Seoses podcastiga tulid mõned mõtted ja panin need kirja. Lühike sissejuhatus podcastile. Ise olen sertifitseeritud elektrik, töötanud 15 aastat naftaplatvormidel, tegelen erinevate elektritöödega, kiirgusohutu elektripaigaldise, ehitamisega ja ka elektromagnetkiirguste mõõtmisega. Tegelen ka helitöötluse ja muusika tegemisega. Seoses tuukenite massplaneerimisega Eestisse räägitakse üsna palju infraheli negatiivsest mõjust tervisele. Infraheli naine, mida kõrvaga ei kuule, tekib siis, kui tiivikulaba möödub tornist. Tuletaksin meelde, et meil on väga palju ühiskonnas erinevaid tegureid, mis mõjutavad inimese tervist, näiteks rämpstoit, joogivesi peab olema puhas ja me elame ühiskonnas, kus on väga palju elektromagnetilist kiirgust. Tuukenite poolt tekitatav infraheli on madalsageduslik akustiline energia. Minu erialase kogemuse põhjal on kodudes ja kontorites number 1 kiirgusallikaks tavaline elektrisüsteem, elektrikaablid, elektriseadmed. Elektrisüsteemi kiirgus on samuti madalsageduslik elektromagnetiline vahelduvvoolu elektrimüra. Olen otsinud, kuid ei ole leidnud ühtegi uuringut, kus on käsitletud madalsagedusliku elektrikiirguse ja madalsagedusliku infraheli koosmõju. Armastan teadust ja huvist infraheli suhtes tegin Marianaga podcasti. Tema on tegelenud selle teemaga 30 aastat. Tuukenite infraheli tekitab reostust juurde juba olemasolevale tehislikule elektromagnetilisele reostusele. Elektromagnetkiirguste kahjulikust mõjust inimese tervisele räägiti juba 75 aastat tagasi. Head vaatamist ja kuulamist. Täna räägime sellise huvitava inimesega nagu Mariana Alves Pereira, kes on väga pikalt tegelenud akustikaga ja erinevate helide mõõtmistega. Aga räägime temaga lähemalt. Hello.
Hello.
Can you please, first of all, explain a little bit your academic background?
Yes. First of all, thank you for inviting me for this podcast. So my name is Mariana Alves Pereira, and I have a bachelor's degree in physics from the State University of New York at Stony Brook. I have a master's degree in biomedical engineering from Drexel University in Philadelphia, and I have a doctoral degree in environmental sciences from Nova University in Lisbon, Portugal. My studies in relation to infrasound and low-frequency noise actually began before my bachelor's degree. I was working first for the Portuguese Air Force as a technical translator. And in this Air Force base, there was a medical unit, and they were undergoing research on the workers because the workers were sick. And so I started translating the work of the medical unit. And that's how I got into this.
I have heard that the big engines
Yes,
on the airplane,
it's true.
They make also infrasound. And I have heard stories that some guys are walking, inside the engine.
Yes. That has been documented not only in Portugal, but it has also been documented in the US aboard aircraft carriers, for example, but not only. So in military workers, you understand that this is military levels of noise and constant. So some people are more susceptible than others, and they react very badly. And it in these workers, what is seen is an absence of consciousness. They don't realize what they're doing, and they put their body, their physical body in danger, but they don't realize what they're doing.
In Estonia at the moment it's time where they want to start putting up quite a lot wind turbines. They say, of course, that the electricity will go now cheaper, but if you think clearly, electricity will not go cheaper. But the second thing is sounds, acoustics, what the wind turbines are making, and of course infrasound. Can you explain a little bit about
Yes.
sound
So,
spectrum?
Usually people are more familiar with electromagnetic spectrum, right? We all know that there is the spectrum of light, and we only see light in a very small region of this big spectrum. And then we have X-rays, we have radio waves. May I show a slide to exemplify better? Okay, I'm going to share, if you all don't mind, I'm going to share a slide because pictures always speak 1,000 words, and it's just simpler for the public to understand this complex issue of sound with pictures. So, here on the top part, you have light, and we only see in that little piece of the whole spectrum. Below, you have the acoustic spectrum, and you see we have infrasound on the left where we do not hear. We have ultrasound on the right, the blue, which we do not hear. And we have also a segment which is audible. Okay, so there is a similarity with electromagnetic spectrum because there are things outside of the human perception that can be occurring. So this is 20 hertz is the value that is classically given as the limit of which we don't hear anymore. So below 20 hertz, it is considered that we don't hear it.
I'm measuring actually electromagnetic fields, and I'm an electrician, and I have worked 15 years in oil rigs. So I know how important it is to have right equipment to measure something. For example, electromagnetic fields, I have different equipment like this, something like this, and for higher frequency like this. But how it is with the low noise measurement?
Well, basically, historically, there has been no need for low noise measurements because historically, we have understood that exposure to noise causes hearing problems, right? People that work with machines, the older guys, and they can't hear because they've been working with machines for so long. We know this, right? So what did science do? Like, as you understand with the electromagnetic, if you just want to measure, let's say, visible light, right? So you go in with a machine that captures everything. You don't need everything. You just want the visible light, right? So you find a machine that only measures visible light because that's all you want. Well, this is what happened with acoustics. The idea was noise, we have to protect people from noise that causes deafness. And so they developed a machine that goes into the environment and only measures the noise that causes deafness. So anything outside of that type of noise that causes deafness is not measured. It's more serious than that. It's not considered necessary to measure because it has no effects on health. You see, it is considered wrongly that if you don't hear it, then it's not a problem. You see, if you bring this now to the electromagnetic analogy, what you're telling people is that if you don't see it, it's not going to hurt you, right? So we know that isn't true with X-rays, with ultraviolet, with microwaves. We don't see them, but if we are exposed to them enough time, they can hurt us. This hypothesis, this is not even put forth in acoustics. It is said, it is not written in stone, but almost, that if you don't hear it, it won't hurt you, right? So science has developed ways to go into the environment, acoustic environment, and only measures sound, that which is heard by the humans and can make you deaf. That's all they do. Of course, in the 1960s, during the development of the United States and the Soviet Union space programs, infrasound became a problem for the workers. So the first studies of the impact of infrasound on health were done in the 1960s within the context of the space programs, both in the US and in the Soviet Union. Then in the 70s comes the industry, right? So people are working now in factories for now 15, 20 years. They are going deaf. There starts to become a movement of how do we protect the hearing of workers, right? So they develop the hearing blockers, right? The hearing protectors. And they develop legislation that says workers can only be exposed for this amount of noise, all for the hearing. Now, in the 1970s, there was a symposium organized by the French National Research Council entirely dedicated to infrasound. So they really wanted, now what was happening? There was no wind turbines in the 1970s, right? So why are they talking about infrasound? It's the airports, it's the ventilation systems, it's the transport systems. All of these were starting to become a problem for public health. So then we're in the 80s. And what happened in the Soviet Union was they actually made legislation against infrasound. So still to this day, the Russian Federation has legislation against infrasound. They have limits on the levels of infrasound that you can have. And they do it for 4 locations. 2 are occupational and 2 are public environments, so public health environments, residential environments. In the West, we stuck with the DBA, right? Now, what is this DBA? This is the machine, so that we were speaking, that allows, not a machine, it's a filter on the microphone that allows scientists to go into the acoustic environment and they only measure what humans hear, nothing else. So could I show another slide for people to understand what this means? So if they're only measuring what people hear, what else is there, right? There's all other stuff, right? I'm going to quickly find the slide that I want to show, and you will see it's here.
In the meanwhile, I will say that first time last year in November, our health board or health department was first time trying to measure infrasound in a house. I have pictures of the measuring equipment they used, and I will show pictures. I will share a screen and show Now I want to share something.
It's your
and I cannot. Okay, I think here. No.
Now I see. It's
Can
a
you
sound
see this
level
picture?
meter. It's a microphone. No, it's a microphone.
Okay. Yes. Yes, there was two microphones, one in a house and one outside. And as we can see in here, the measurement sound pressure level, dBA. Yeah, and that is what official health department is measuring. Maybe you can explain now why we cannot
Yes,
do
this was
dBA.
very helpful, actually. Yes. So the dBA is what is usually measured. I am now going to share a screen of what that means. What does it mean when we measure in dBA? So I'm sharing now, I hope. Yeah. Can you see my mouse? You see it moving around?
Yes.
Okay, so dBA,
Yes.
you see these red bars here? This is dBA. When they say they measure in dBA, this is all that they are measuring. All of this, only this red stuff. And of course, if you look here, this is all that's there, really there. But this is all that they are measuring. Now you see, please understand, why are they only measuring this? Because this area of the spectrum, the frequency range that is covered by the dBA, is the one that makes you deaf. This is not a bad thing, the dBA. The dBA has been very useful in preventing and eliminating risks of going deaf. However, when you come to infrasound, you can be exposed to a lot of infrasound, but deafness is not what you're going to have happen to you. You see, exposure to infrasound does not cause the classical deafness. So it's not included in the measurement. So as you can see, this, what I'm showing now here, so this is the graph that goes from the frequency of 0.5 hertz all the way to 1000 hertz. And you can see here, so remember it was 20 hertz. Below 20 hertz, we don't hear it. Well, all of this pink stuff is not measured when you use the dBA. And all the stuff that is between 20 and 250 hertz, it is measured by the dBA, but it is de-emphasized. What this means is, as you can see, look here, at 100 hertz, the dBA measured this amount, the red. But what is actually there is the pink. You see? So starting at about 800 hertz, the level reflected by dBA and the level that is actually there in the environment is completely different, as you can see. And below 20 hertz, it's not even measured. It's completely ignored if you use the dBA.
And this 1/3 octave, maybe you can explain that that means.
No, I for the public, the general public, it's the easiest way to think about this 1/3 octave is if you think of the octave like a meter, right? And we divide the meter into decimeters and then centimeters and then millimeters. We do this, yes? So when you have the octave and then you have third octaves, it means that you divided the octave into three pieces. Like the meter, when you divide into decimeter, what do? You divide the meter into 10 parts. With the octave, it's 3 parts. Now, if you take a meter divided into decimeters. Do you think it will be good to measure an ant, a very small thing, and you only have a decimeter meter? It's very difficult to measure small things if you only have a meter, right? How can you measure an ant with a meter? You have to make millimeters, right? Then you can measure an ant. This is what we do in acoustics. Instead of taking the octave and dividing into 3, we take the octave and we divide into 36, so like millimeters. So I will show you an example of what happens when you do this. It's the same picture as before I'm going to show you, but this time it's with the 1/36th octave. You see, we still have here the frequencies. It goes from 0.5 to 800, but now for each octave we have 36 data points. With the methodology implied by legislation, in each octave we only have 3 points. Now for each octave we have 36 points. This allows a higher resolution. For the layperson to understand better, maybe, you see, legislation requires that you look at the acoustic environment like with a magnifying glass. We are using microscope. So, of course, there are things that we see with the microscope that you don't see with the magnifying glass. And here is again the example. This circle, the red circle that you see here in this picture, you see there are peaks in that circle. Those peaks, it's called a wind turbine acoustic signature. You can only see these peaks if you go and look with a microscope. You won't see them with a magnifying glass. You see, we did not see these peaks in the previous graph, right? It was all the pink and the red. Here we can actually see it. Please note, here, this line is, this line here is 20 hertz. So all of this stuff that's in the circle, these peaks, it's all happening below 20 hertz. It's all happening in a part of the acoustic spectrum where classical science says you can't hear it and therefore it won't hurt you. You see, this is the seriousness of the situation where the agent of disease, which is noise, is not being properly characterized, and therefore people are not knowing what is there really in the environment. So I don't know if this helps, but
I also do music, so I don't know, is it a good example, but if you take an equalizer, you have their bands. You can filter out. It's like if you have an equalizer with 3 filters, or you have
exactly.
with 13 filters.
Which one equalizes best?
You have actually publications. I saw in one place you had over 100 publications.
I have no idea. I haven't counted them. I'll send them to you and you can count them. How's that? I have no idea. Look, my first paper was published in 1999. And since then, we've published a lot. I'll send you. It's 16 pages of publications. So I'll send, you can count them and then tell me, please. So that the next time, this is very embarrassing that I don't know the number, but that's not important how many Yes, I love science. To know, just to know. This is forbidden nowadays. You cannot know just to know. There has to be an economic benefit in what you want to know. Otherwise, nobody will support you in wanting to know. If there's not an economic benefit, a perceived economic benefit, nobody cares. It's disgusting. There's very, very little basic science, basic, with no agenda for economic benefits, just to know. Let's just find out. Anyway, sorry.
In scientific world, I think it is
Well, it depends on the scientific world you're talking about. No, it depends. See, it seems to me nowadays that there are two very distinct scientific worlds. And there's the scientific world, which I call the old world science, so the old school science. And this is the school of science under which I was educated, and where the scientific method has a certain validity in terms of medical sciences. I was taught under old school. Dose and response relationships have a certain importance, and they are measured with certain methodologies in accordance with the scientific method. I don't see that happening today. I see scientific publications with let's say, with extremely flawed methodological protocols and procedures, and they get published. Nobody is looking apparently at the methodology. I don't know what's happening. I'm not a part of that world. When the scientific method is overrun, so while number of publications might be important to a lot of people, I find what is published, the actual juice of what is being said, is much more important. I can have 100 publications that are bullshit, and then I can have 3 which are very good scientifically. So this thing of number of publications, and also nowadays, oftentimes publishing is a very political situation. And if you go against what has been termed, which I don't know what it is, there's this term called scientific consensus. I'm not entirely sure what that means. But apparently, if your science goes against this scientific consensus, which again, I don't know what it is, then you're not published. This is not new. There were a lot of papers back in the 50s and 60s, apparently, that were in physics that wanted to get published, and they weren't published, not because they were wrong or that they were methodologically flawed. They just weren't published because they went against Einstein's theory of relativity, period. So, science, unfortunately, is made by human beings, and human beings, unfortunately, can be very biased and very political and not exempt. For scientists, you should strive to be exempt. You only focus on the science.
Let's talk about little bit this vibroacoustic diseases. I have written that you have some publications about that. First, I will show a video. This is now noise, what we can hear.
I can see it.
Can you see that?
Yes, a little bit. There's 2 sounds there, right? There's the and there's the
yes.
Awful.
So I have heard that whales don't like infrasound about in the sea. But okay, let's talk about humans and these vibroacoustic diseases. What does it mean?
The term vibroacoustic disease today is what has been called in the past by other authors back in the 50s and 60s. They called it a vibro noise pathology. Other people called it the vibration pathology. You see, so by the 1980s, when Dr. Branco, under whom I worked, was studying his workers within the Air Force Base, new technologies had existed compared to the 50s and 60s. We had MRIs that they didn't have at the time. We had ultrasound that they didn't have at the time for cardiology. So new techniques of study were implemented among the Portuguese aircraft technicians that were working at the base. So a new clinical picture was able to be defined. So because of Dr. Branco's work, which lasted, 30, 40 years, but we are able to today, for workers, for people who are exposed to noise at work, we are able to define what is called the clinical stages. So after 1 to 5 years of work exposure, what kind of symptoms you would have. This is called the dose response relationship, which is so very important in medical sciences. So after 5 to 10 years of work exposure, you have a different set of symptoms that may appear in the workers. And then after 10 to 15 years of exposure and higher, you have the most severe symptoms that can appear in workers, right? So this is vibroacoustic disease. Now, what then happened starting in the early 2000s, 2001 and 2003, our group was contacted by the general public. And the general public tells us, please, you have to help us. We're exposed to infrasound and low frequency noise in our homes. And we're like, no, this can't be possible. Look, we're dealing with military aircraft. We're dealing with big machines. How is it possible that these people in the middle of Lisbon would have vibroacoustic disease? Not possible. But we went to their house. We measured the noise in the old way, so 1/3 octaves, because we had no other machines at the time. And we gave the people who were complaining from the general public, we gave them the same medical tests that we gave the workers. And this is where we were completely surprised. The people living in a normal house in Lisbon had the same pathology as the workers. We couldn't understand this because the levels of noise that the workers were exposed to was so much higher than what the people were being exposed to in the house. So much higher. How could these people be so sick? And then we understood. They're sleeping in it. They're sleeping in it. The worker goes home at the end of the work shift. People, normal people, when your residence is contaminated with infrasound and low frequency noise, you're sleeping in it. So your exposure time is much larger than in workers. So while vibroacoustic disease was initially identified among workers exposed to noise, later we found that in the general public, there were people developing vibroacoustic disease because they either lived near places that were now doing this acoustic pollution. Again, this is not legislated. So they can do whatever they want. I mean, infrasound and low, as current EU legislation stands, infrasound and low frequency noise can basically have any levels they want because it's not legislated. It won't make you deaf. DBA won't measure it, but it'll be there and it'll be affecting your health, whether it's in urban settings, whether it's because of wind turbines in rural settings, or whether it's occupational. So that's vibroacoustic disease and how it developed.
In my field, in electromagnetic fields, we have actually quite a lot of publications. Since 1950s, there was information. So I know there are publications that say it's no problem, but if you see who has founded that.
Precisely. So that's why when you ask me how many publications I have, I'm like, it's the quality of I can have 1,000 publications and they're not worth anything. You know, they're discussing why the sky is blue, or, you know, that's not a good example,
Yes,
but,
exactly.
you know, discussing, you know, something irrelevant or not so. Sometimes, you know, some of these studies, they're just a revision of other studies. And so how can you compare, which is required? You have to do revisions of other studies. But how do you compare a paper, a study, which is a review of other studies, and now it's a publication on your list of publications, and now you have a study that is actual science. You're measuring, you're doing, it's not a review of other studies, it's actual science. Are these papers the same? Because today they are. It's just another publication. 1, 2, 3, 5, 6, 7, you know. So I'm sorry. I feel silly that I don't know how many publications I have. Now that you mention it, I really don't know. 16 pages. Look, on a Word document is 16 pages, so I can send them to you. You can count them.
Maybe you can say a little bit about this. I have heard this word nocebo. Then we have placebo.
Well, you see, the human brain is very powerful, right? And I'll take the example that mostly everybody has heard of, or in movies or something, which is called the fictitious pregnancy. Some women, they put in their brain that they are pregnant. They're not. But the brain is so powerful. This is the Nocebo Effect, where you imagine in your brain that something is happening, right? In terms of your body. So now let's take this woman who's obviously ill, but she goes to the gynecologist. And you see, in these cases where women imagine that they are pregnant, they have all the symptoms. Everything of a normal pregnancy appears in their body. So the woman goes, under these circumstances, the woman goes to the doctor, right? And the doctor sees, oh, yes, you must be pregnant. And now we must do an ultrasound, right? The echo of the baby to see if everything is okay. You do the ultrasound and there's no baby. That's when you know that this woman is undergoing a nocebo event. It's called officially, it's called psychosomatic, meaning your brain thinks it's there, it makes it happen in the body, but it's not there. You know, it's psychosomatic. Now, in medical sciences, like the woman with the false pregnancy, the doctor does not know that this is a false pregnancy. Only when does he know? He only knows after he confirms that it's a false pregnancy, after he gives her what? A medical test. So, it is claimed that the people who are living near wind turbines and near wind power plants are getting sick because of this nocebo effect, meaning they are thinking that the wind turbines are going to make them sick, and therefore they become sick. This is what is called the nocebo effect as applied to wind turbine people or people living under wind turbines. This is, of course, false. These people are not undergoing a nocebo effect, even though a lot of people would like to think so. And it's very easy to show they're not if you give them medical tests, right? Like the pregnant woman. Look, it might be nocebo, huh? It might be. Let's go and check. Let's go and prove that it is by giving them medical tests. You will find that it is not a nocebo effect. And if you give the proper, relevant, and pertinent medical tests, you will indeed identify pathology, common pathology among all these people. But the most undeniable fact that the people, what they are suffering is not nocebo, the most undeniable fact is the animals. Because the animals are getting sick and dying. So you see, if you want to say that people who live under or near wind turbines are developing health problems due to a nocebo effect, well, how do you explain the animals? Is that a nocebo effect also? Are the pigs and the geese and the cows and the sheep and the mink, are they all thinking, oh, I don't like wind turbines. I think wind turbines are making me sick. And that's how they get sick. If all these animals and rabbits also, so all these animals are thinking this, and that's why they're getting sick. You see, so while the nocebo effect does exist, while it's psychosomatic, officially in terms of medical sciences, it would be a pathology of psychosomatic etiology, so of origin, psychosomatic origin. Unfortunately, this is not the case with people who are developing health effects under wind turbines. So that's the nocebo effect. I hope that was clear.
Yes. Actually, on this electromagnetic fields, we can measure in human body a low frequency electric field. If we are in the middle of the wires what radiate to the body, we can measure exactly what is the body voltage of our alternating current. But in sound, it's I understand it's quite difficult to measure it somehow in the body.
I don't know of any device that measures that in the body.
What is the distance should be? I have heard that it's even 50 kilometers can be detect low frequency sound.
Emanating.
Should be the distance 10 kilometers.
Well, so science doesn't know. Okay, science does not know what is a safe distance between wind turbines and home. Science does not, you see, it really also, the amount of infrasound that is coming off of the wind turbine, how it propagates and how far it propagates depends on the terrain. So if you have mountainous regions, or if you have large bodies of water, or if it's flat land, the propagation will be different, you see. So, of course, if it's flatlands, I understand, and I've seen some pictures that in Estonia, a lot of it is flatland where these wind turbines are. So if it's flatlands, yes, kilometers and kilometers distance, it will be picked up. I'd like to mention something just so people understand. The Nuclear Test Ban Treaty. So this was a treaty that was signed all over the world, or almost. And what they did is they put infrasound measuring stations, there's 60 of them, around the world. Because now if anybody explodes a nuclear bomb, the infrasound detectors will detect it. You can't explode a nuclear bomb without massive amounts of infrasound being produced on planet Earth.
Infrasound is also measured in Bavaria, however, in order to identify possible explosions from nuclear weapons. Here, the Federal Institute for Geosciences and Natural Resources, the BGR, operates a measuring station, the I-26DE, on behalf of the German government. The I-26DE is part of an international monitoring network designed to ensure that the terms of the Comprehensive Nuclear Test Ban Treaty are observed. The BGR achieves this with ultra-sensitive measuring systems. Looking more like showerheads than high-tech equipment, the inlets for the infrasound are located close to the ground where the rushing of the wind is least noticeable. Wind noise would affect the readings.
And so the 60 infrasound monitoring stations all around the world, they have been set up to detect infrasound. Now, the monitoring station in Germany had problems because they put a wind power plant nearby. So the measurements of that particular infrasound monitoring station, they had to change some things so that they could continue to monitor properly in the presence of the infrasound coming off of wind turbines. So you see, infrasound propagates kilometers and kilometers of distance, kilometers and kilometers. So yes, 50 kilometers, you know, if you could, I wouldn't live anywhere closer than 50 kilometers to a wind power plant. At least I try to not live. So.
Because of this, back in 2004, the BGR examined the infrasound emissions from a single wind turbine. The scientists were mainly interested in assessing how far from the wind turbine it would still be possible to register infrasound emissions. Their measurements were analyzed at the BGR's National Data Center. Lars Serrana comments on the frequency spectrum.
At low frequencies, our infrasound sensors picked up very clear signals from the wind turbine. Every time the blade passes the tower, large air volumes are compressed and sheared. This signal produces an infrasound signature, which we refer to as blade pass harmonics.
The blade pass harmonics of the wind turbine are individual frequencies. They emerge from the background noise with a distinctly higher acoustic pressure level, in other words, with more energy. Lars Serrana explains.
If we follow the blue line with the mouse, that is the background noise. The distinctive elements of it here represent the contribution from the wind energy plant, the blade passing harmonics, when the blade passes the tower and generates an infrasound signal.
The wind turbine studied in 2004 was very small, barely 0.2 megawatts. For bigger wind farms, the scientists made a model calculation.
It takes us to a dimension where we can say that a 5-megawatt wind turbine would possibly generate a detectable infrasound signal even from a distance of 20 kilometers.
Can you please a little bit explain what is dB measuring? Because actually we are measuring sound pressure, what's
Yes,
called Pascal, I guess.
You see, the dB is a scale that measures in reference to something, right? So when you have a dB, it's always in reference to something. There's always a basic reference level, because the dB is giving you a level. It's not a number. It's not a quantity, physical quantity. It's giving you a level, and therefore it requires a reference. For the definition of the acoustic dB, it is referenced to 20 micropascal. Very, very, very tiny amount of pressure. Why? This number, 20 micropascal, is the minimum pressure necessary for your ear to hear something at 1000 hertz. So if you have a sound at 1000 hertz, all you need is 20 micropascal of pressure for it to be heard. And that's why we use, when we define dB, some place has 50 dB, it means that it's a level referenced at this 20 micropascal. So, because of course, sound is a pressure wave, right? It goes in the air as a pressure wave. So when you're measuring noise or sound, the microphone is measuring how much pressure is coming in. So that's why we use the dB reference to the pressure of 20 micropascals.
There is a lot of confusion about these decibels, because there is a lot of areas where is used decibels, like
Exactly.
in electromagnetic fields, when we measure tower strength, it's in dB, but I am actually measuring voltage.
At the 10 to the 4 watts, the reference, the dB. So while for noise it's 20 micropascal, for you guys, for the watts intensity, if I'm not mistaken, it's 10 to the 4th watts per meter or something like this. It's a different reference. And that's why you can use the dB scale to measure things also in electromagnetism.
Is there something you want to say, Estonian people? Because at the moment the plan is very big, to put everywhere very big wind turbines. To be strong?
I deal with people suffering under wind turbines for many years now in many, many different countries. So I don't believe, while I love Estonians, I don't believe that they are so different human beings than all the other people in the world who are suffering under wind turbines. So, speak to your politicians. I don't know what to say. The science is there. I know it's very difficult. The people who desire to put wind power plants all over Estonia, I've seen the maps, they're very powerful. I believe that they believe that it's going to be economically beneficial for them. I believe that they believe that there is no problem for health. Of course, I also believe that they are misinformed. Try and not have them near your house. Try and a plan B for in case they come, what do you do? You have to take into account if you have children in the house, if you are a young couple and you wish to have children in the future, You have to see what kind of lifestyle you want. Please be careful. Protect yourselves. Inform yourselves and protect yourselves.
Yes, I think the informing is most important because a lot of people do not have information at all. Thank you very much, and we hope we can inform a lot of people to understand that this is a problem.
You're very welcome.
Seda sõna ise meile ju ometi ei seleta. Kui inimene sundidega kimpu jääb, siis püüab ta küll asju oma südamele selgeks teha, aga süda teab, mis tema teab ja ei hooli seletamisest suurt midagi, vaid tikub minema ikka oma teed. See maailm, milles liiguvad kureparved ja lõkendavad sügisvärvid, on inimese maailm. Ja et inimese maailm ei laiu mitte üksnes inimese ümber, vaid ka tema sees, siis on inimeseski midagi kureparvedest ja nendest saladuslikest jõududest, mis linde parvedesse liidavad ja liikvele ajavad, ja neist teistestki, millest pole õieti teada, mis nad kureparvedega veel teha võivad, neid uutesse päevadesse või hukule vastu juhtides. Siis on inimeseski midagi kureparvedest ja nendest saladuslikest jõududest, mis linde parvedesse liidavad ja liikvele ajavad, ja neist teistestki, millest pole õieti teada, mis nad kureparvedega veel teha võivad, neid uutesse päevadesse või hukule vastu juhtides.